A rainbow that appears as a seven-colored arc in the sky is one of the most beautiful optical phenomena. An observer can see a rainbow on a rainy day only when the sun is behind her and the atmosphere before her is filled with drops of rainwater. The sunlight passing through the water drops present in the atmosphere undergo refraction, dispersion, and internal reflection to form a rainbow. If the sunlight undergoes one internal reflection in the raindrops before emerging out, then the rainbow formed is called a primary rainbow. Primary rainbow is bright and narrow with red color at the outer edge and violet at the inner edge. Let us understand the formation of a primary rainbow. Consider a ray of sunlight, AB, incident on a raindrop as shown. The sunlight refracts through the water drop at point B and is dispersed into its constituent colors. The red light with the longer wavelength is bent the least, and the violet light with the shorter wavelength is bent the most. A part of the light is then internally reflected from the back surface of the water droplet. The path of the least deviated red light is represented by BCD, and that of the violet light is represented by BC-D'. The light is again refracted when it exits out of the drop of water. It is observed that the emerging violet and red colored light makes an angle of 40 and 42 degrees respectively with respect to the incoming sunlight. Now consider another water drop just below the one considered earlier. The sunlight that enters this drop also propagates in an identical way. An observer viewing a primary rainbow receives red light from the drop at the top and violet light from the drop at the bottom, and other colors from other drops located between them. This is the reason why the primary rainbow is always formed with red color at its top and violet color at its bottom. Under favorable conditions, a broader but a fainter rainbow may also be seen along with the primary rainbow. This is known as the secondary rainbow. While forming the secondary rainbow, the light rays undergo two internal reflections inside the water drop, and due to this, it is fainter than the primary rainbow. Note that the colors are reversed in the secondary rainbow with red color at the inner edge and violet color at the outer edge. This is because the observer viewing the secondary rainbow receives violet light from the water drop at the top and red light from the drop at the bottom. In the case of the formation of a secondary rainbow, the emerging red light makes an angle of 50 degrees and the violet light makes an angle of 53 degrees with respect to the incoming sunlight.